Right, so today I'd like to talk about hash tables, a really important area, especially for older languages. So just to give you an idea why these are not particularly prominent in Python, it's because it was made in the 1950s and used extensively in older languages such as C. So if you're doing the Cambridge exam, you can expect to use pseudocode and tables for any questions. Python itself has built-in hash tables in the form of dictionaries, and these are very easy to use and take a lot of the grunt work out of things. So what are the problems with these old languages? Well, arrays were a fixed size, but they were fast. Linked lists can grow, but was slow. So the idea of a hash table tries to combine both of these benefits. How it works? Well, you come up with a key value, which could be cat, dog, whatever data it is that you want to put in, and it can be any type of data. Then the hashing function processes it and it puts it into a hash table. A little bit more explanation here.
So what is a hash table anyway? A hash table is just an array coupled with a function, which we'll call the hash function. The hash function takes a piece of data as input, we'll call this a key, and outputs an integer commonly referred to as a hash value. The hash value maps our key to a particular index in the hash table. You'd initially use the hash function to determine where in the hash table to store a given key. Later, you'd use the same hash function to determine where in the hash table to search for a given key. For this reason, it's crucial that a hash function behaves consistently and outputs the same hash value for identical keys. Know that hash tables can be used to store data of all types, but to simplify things, we'll focus on strings for now. Here's a simple hash function for strings. This hash function computes a hash value based on the first letter of the key. Apple begins with the letter A, so it's mapped to index 0 of the hash table. Similarly, banana is mapped to index 1, and cat is mapped to index 2. If a friend asks if the word dog is in the table, we'll input dog into the hash function, which will output a hash value of 3. Since dog is not stored at index 3, we can say with confidence that dog is not in the table, even though we've only checked one of the hash table's 26 indices.
Let's have another example. Again, same thing, you've got the processing going on there and going into a hash table. You've got apple, banana, cantaloupe, kiwi, mango and pear. The problem is if we put something like berry in, we've got a collision. Now there are a few ways to deal with this, and I'm going to suggest 3 of the easier methods available. Number 1, instead of having all of these things going on, we have linked list, a pointer to a linked list, so that for each collision it just goes into the first part of the list and it goes through. So the table has a pointer to the first item in the linked list. However, if you want to keep everything inside this table, what you have to do is possibly have an overspill area. So if there are any collisions, it knows to go straight to this overspill area and work out which one is there. Another solution is open hashing, and that just goes down to the first free area. Now there are more complex solutions, but as far as Cambridge is concerned, those are simple enough ways to deal with it. Right, let's go through a worked exam question. So we've got some data about sports club members, and they're stored in a random file of records. The key field of a member record is the member ID, and it's a range of 1000 to 9999. Other member data are stored, and a hashing function is used to calculate a record address. The random file initially consists of dummy records, so basically just some space there. And the dummy records are shown by member ID set to 0. The hashing function looks like this, and this has been written in pseudocode. So function hash returns integer address member ID mod 100. Return address end function. So let's have a look at the empty thing. So the new members with IDs have 1001, 3005, 4096, 2098, 7002. I'll do the first one with you to help you go through it. So the first answer is 1001 because of that modulus. Okay. So hopefully you've worked out how the thing works. If not, let me go back for you. So the ones you're going to do next are 3005, 4096, 2098, 7002. Pause here to do it. I'm going to reveal the answers in a few seconds. Okay, so the complete answer, as you can see, 1001, 7002, 3004, 4096 and 2098. You'd have got marks, 1 mark for the first 3 and 1 mark for the second 2. Right, let's move on to the next part. They want you to complete the pseudocode, the new address, seek and the put record. And again, this is worth 4 marks, so quite generous actually. Okay, again, try and do it and I'll reveal the answer in a minute. Okay, so this is what the answer would look like. Next, before the records can be saved, to complete the file membership, the file needs to be open. So this isn't particularly to do with hash tables, this is to do with file management. But notice above the AS level, you're expected to deal with randoms. So have a go at that. You can pause it. Okay, now the answer is try open file for random, except again with 2 marks, end try. Moving on to the next question, there are 2 follow-up questions. A record with member ID 9001 is to be stored. Explain the problem that occurs with this record is saved. So you've got 2, but remember you're not just got to identify, you've got to describe. Explain rather. And number 4, describe a method without changing the function hash to handle the problem identified in B part 3. So have a go at those. I'll reveal the answers in a second. So yeah, that was it. Collisions, they allowed synonyms, which isn't in your textbook, and the previous record could be overwritten or it could just crash the program. And 4, you could create an overflow area, or you could store the overflow record at the next available address in the sequence, or you would have to redesign the hashing function to generate a wider range of indexes or create fewer collisions. And the final question is to write the pseudocode to implement the method you described in part B4 and choose line numbers to indicate. Now I'm going to give you a sample answer, but please be aware there are many other ways you could have done it because you've seen there were 3 options there. Pause again. And there is your final example answer. Thank you for listening.